method of transformations, and it's not, these aren't methods. Like if you go look at it online, you won't find something that says this is the method of transformation. This is what your book is calling it. To me, they're not methods. You're just doing stuff. So one of the assumptions in the distribution method, which is not really a method, but it was a way to find a distribution given that you know some distribution and there's another function of this distribution, is that you need that function h to be non-decreasing. You need it to be going up, straight up or straight down. You can't have like a sine wave or something. And that's what allowed you to say, look, because this one's increasing, then I can chop it off and just replace it, the substitution thing that we were doing. When one function's increasing, its maxes and mins are at the same place, the same x values that the original function was increasing it at. So that's what allows you to do this. So I tried to explain it this way, that when you have this is the definition of the distribution in U. The next step right here in step 1, when you do this, the fact that you're allowed to invert and solve for y and then use your original distribution in terms of y, the reason you're allowed to do that is because h was also increasing. And for you guys in real analysis right now, I think soon you're going to be going to functions. Have you guys gone to functions yet? Soon you're going to go to functions, and they'll talk about things that, is this true or not? True-false questions start rearing up there. Some of the ones that I gave you in here are very similar. And so they'll ask you questions about whether something's true or not, and you always have to think of things like sine functions to make it blow its condition. Because usually things are true for things that are increasing or decreasing always. We call those monotone functions. Boring functions. They don't go up and down. And that's what allows us to do it, that solving business and working with the y variable. So they've actually drawn a picture in your book so they can see that, but I kind of see this better with the algebra, why that would be true. So just to remind you, you were supposed to find this function. You will know information about this function. Doing the algebra and putting it in this, preserving the inequalities occurs because h is an increasing function. And then don't forget the final steps to take that derivative, right? Once you got the distribution function in the distribution method, you take its derivative and it gives you the PDF. And that's generally the question that you've been asked so far, find the PDF. On your homework, there's a whole bunch of find the PDF, correct? Just to, so this method of transformation, I said it's not a method. Here's what they're doing. They're saying, okay, when I take the derivative, I could use chain rule. And I don't have to go through any of that distribution method. I can just plug and chug into this chain rule. I can bypass all the stuff I did in the distribution method. That's what it is. That's what they're calling the method of transformation. With me so far? You guys must be very good at this point, looking like you're paying attention when you're really, really tired. Tell me the secret, because I need it too. Plebes told me this one. No one will stop a praying person. Colonel Bates gave me a good one. Write in a journal. I was amazed that he always writes in his journal every night. And he's like, actually, in meetings sometimes when I feel like I'm falling asleep, I start writing in my journal, so this keeps me awake. Like, it's a good idea. All right, so let me walk through a toy example, so you can see it step by step what to do. Recall this example. This is the one that I had previously that I did with the method of distributions. It shows up in this section. The first step is the same as before. You take y and write it in terms of u. Notice up here I have this, can you see my mouse? Right up here you have the u equals 3. That's the new function. And so the first step is the same as before. You take the u and write it in terms of the y in terms of the u. That's your h inverse. Remember when you're little and you had to find inverse functions? That's the same thing. Second thing is you find the derivative. MA 104, they're doing this right now, chain rule. So this is copied and pasted on the next section. So all I did is I'm finding that derivative. There's my original function. I have the inverse function up there in case you didn't copy it from the previous slide. So f in y of h inverse of u just says plug in h inverse of u for y. So h inverse of u goes in for y wherever the y was. So it also goes in on the inequalities. And we did this in the last one. It's the new boundaries that you're looking for. That's the one part of the chain rule formula. So it's the left side of the chain rule formula. Good? The derivative of the inside, the inner function, is the derivative of the inverse with respect to u. That's 1/3. I just popped it up there in the purple. And then you just multiply them together. So fy of this times this is you just bring the 1/3 in. And if you look back at what we did last time, that's exactly what we got the same answer. So there's the PDF for, so that's a PDF for FU.